talk about substitution. This is a concept that's used in many various facets of occupations and just different day-to-day things. I know substitution when I cook. I can substitute heavy whipping cream with whole milk and butter. You can do different egg substitutions. Substitution is something very common when cooking. It's also common in English. For instance, this is an English sentence that would say, the dog ate my homework. But we can substitute this word for a lot of different things, like the Smurf ate my homework. Or perhaps the cat ate my homework. I didn't change anything about the sentence except one part. And in math, that's exactly how substitution works. This is a math sentence. It is composed of different pieces, just like an English sentence is composed of different pieces. This sentence tells me that 2 times a certain number that could change, plus 3 times a different number that could change, is equal to 4. Let's say I take that variable x, and I say, instead of x, I'm going to put dog. So I would say the sentence would rewrite in this way. So let's say, I'll do this in a different color. Dog. Okay? And the way I would rewrite the sentence would be 2, and instead of x, I would put dog. And then I would rewrite the whole thing. Plus 3z equals 4. I wrote the exact same sentence, except instead of x, I put dog. Okay? And that's the principle of substitution. Now, this is kind of silly. Maybe not. Maybe this is makes more sense than real math. But the idea is still the same. So I have 3 problems up here to illustrate 3 different types of substitution. Okay? The first one's pretty easy. The second one ties it together. The third one is a combination of a lot of different things. So I'm going to erase this piece right here and work through the first example. Now in this first example, it says x is equal to this piece right here. So I'm going to rewrite this first equation to, except instead of x, because it tells me x is, it can be rewritten, instead of x, I can put 5y plus 9. So in parentheses, I put 5y plus 9 instead of x. And I'll rewrite the rest of the equation. All right, 3y equals 5. Okay, so I rewrote the entire equation, except instead of x, I plugged in this piece. All right, and then you simplify like normal. So distribute, so 2 times 5y and 2 times positive 9. So that gives you 10y, because 2 times 5 is 10y, plus 2 times 9 is 18, plus 3y equals 5. All I did was finish writing the sentence. Combine your like terms. 3y plus 10y is 13y plus 18 equals 5. Solve for y. So subtract 18 from both sides. And if you need to know how to solve equations, I'll do another video where I show you how you solve multi-step equations by simplifying, combining like terms, and isolating the variable. But for right now, you continue the process. So you get 13y equals negative 13. And if you're having trouble with 5 minus 18, go ahead and plug in your calculator, and it'll help you with that. Keep the signs. This is positive 5 minus 18. All right? Divide both sides by 13, and you get y equals negative 1. And so I have y equals negative 1. I need to figure out what x is still. I have half of my answer. I know what one of the variables is. I need to know what the other variable is. All right? So we're going to take y, plug it into one of these 2 equations. It doesn't matter which one. Let's say this bottom one here. So x equals 5 times negative 1 plus 9. Now again, I rewrote the entire equation, except instead of y, I put negative 1. Simplify it. X equals negative 5 plus 9. 1 times negative 5, or excuse me, 5 times negative 1, negative 5, x equals 4. Now these are both 2 halves of a solution. our real solution is going to actually be 4, -1. It's an ordered pair. This is the place where, if I were to graph these two equations, that's where their lines intersect. That's where those graphs would hit. That's why we call it a solution. It's the place where both of them have something in common. And this is the point where they have something in common. Okay? If I plug that point into both of these equations, substituting x, 4, and y, -1, it would get me a true statement. In this case, 5 equals to 5. Or in this case, 4 equals to 4. All right? Same deal here. We're going to try to find the solution by using substitution. And instead of substituting for x, I'm going to substitute for y. It tells me what y equals. So y is equal to 2x minus 9. Now, it's a coincidence. The top equation, again, I'm going to rewrite that one and substitute for y. So 3x minus 2, and then, or excuse me, plus 2. And then instead of y, I'm going to write 2x minus 9. 2x minus 9. Okay? Equals 10. I got to finish the sentence. Equals 10. All right, so I rewrite the entire equation. Instead of y, I plug in 2x minus 9. Simplifying expression, just like we did over here. Distribute your 2. And this is a positive 2, mind you. Distribute 2. So we're rewriting this 3x plus 2 times 2 is 4x. 2 times -9 is -18 equals 10. And simplify this and continue like so. So this is, I'm going to do this quickly and just show you where it leads to and how you get and what the answer would be. You can follow along. If you have questions, ask me in class, it's fine. So this is combining like terms. So that's 7x minus 18 equals 10. Add 18 to both sides. That's nice. It's 18 over here as well. Alright, divide both sides by 7. So you get x equals 4. Again, that's only half your answer. You need to substitute it back in order to find your real, your entire answer. So y equals 2 times 4 minus 9. Y equals 8 minus 9. Y equals -1. Again, 2 halves of the whole answer, which would be 4, -1. Now that's interesting. That's a coincidence that both those turned out just like that. Alright, so this one is a little trickier. And how this one runs is, it doesn't tell you what x equals by itself. It doesn't tell you what y equals by itself. So both of these equations are in this form. We call that standard form. This is in slope-intercept form. And this, we don't really have a name for it. Well, I don't know off the top of my head, and I apologize. But x is isolated. It's by itself on one side of the equation. Over here, that's not the case. So in order to use substitution here, you have to take one of these two equations and rewrite them in either slope-intercept form or with x by itself on one side of the equation. I'm going to use the top equation, and we're going to rewrite that one and isolate x. So I'm going to rewrite the entire equation, and it looks like this. 2x minus 10y equals 8. I'm going to move this minus 10y to the other side, so I'm going to add 10y to both sides of my equation. Okay? This becomes 0, and this leaves us 2x on this side of the equal sign, and 8 plus 10y on this side of the equal sign. Alright, now I got to divide both sides by 2. And right here, this becomes 1. 1 times x is x. And here, when you divide an entire side of an equation by 2, you have to divide both parts. So 8 divided by 2 is 4, and 10y divided by 2 is 5y. Okay? Now I have rewritten this equation. I can now substitute it into this second equation. You don't want to substitute back into your original, because then you'll just get a true statement, and variables will cancel the sums out, and it doesn't quite work very nicely. So let's substitute this into this bottom equation. So I'm going to substitute this here. So 3, instead of x, I'm going to write 4 plus 5y. So 4 plus 5y plus 5y equals 7. So I just finished rewriting that equation. Instead of x, I plugged in this piece right here. Simplify, going through the same process. 3 times 4 is 12. 3 times 5 is 15y plus 5y equals 7. Add your like terms. 12 plus 20y equals 7. I'm not going to finish this process. Due to time, I want to keep this short, sweet, to the point. But the idea is substitution works when you know what one of the variables is, and you can substitute this value in for that variable. If you don't have an equation that tells you one of the two variables, you need to rearrange and manipulate one of the two equations and then substitute back into the second. Okay? So I'm going to go on and move on to elimination.